question asks which of the following functions represents y as a function of x. And so what I'm looking for here is I'm looking for that each x value has one y value associated with it. So if I look at this first one, I can see that the x value 2 has the y value 5. The x value 1 goes with the y value 6. The x value 3 goes with the y value 7. But the x value 2 also goes with 8. So since 2 goes with 5 and 2 goes with 8, this is not a function. The next one, I can see 5 goes with 2, 6 goes with 1, 7 goes with 3, 8 goes with 2. So there's no problem. So this is a function. Okay. On 3, we can see that for the x value 1, say, I have the y values 3 and, well, close to 3 and negative 3. So the x value 1 has 2 y values associated with it, so this is not a function. And then on 4, I can see that each x value has just one y value that goes with it, so so this is, yes, a function. Okay. Number 2. So we have a survey of the U.S. population is done every 10 years. So the first one, what is the average rate of change from 1990 to 2000? And so what I want to do is I want to do the change in the population over the change in years. And so if I look at the population in 2000, it's 281, and I want to subtract off the population in 1990, it was 249. So I can subtract those two quantities to see how much the population changed. And then over the change in years, I want to do 2000 minus 1990. So that's going to be 10 years. So when I do that, 281 minus 249 gives me 32 over 2000 minus 1990 is 10. So that's 3.2. And what are the units of that? So the population was in millions. So million people per, and then the bottom part was in years. So to get the unit of this rate of change, it's going to be units at the top per units at the bottom. So since it was population over years, it'll be million people per year. Oh, I guess I should just write year. Yeah. What was the average rate of change in the U.S. from 2000 to 2010? So we can do a similar thing. It's going to be, again, change in population over change in years, and so that's going to be 309 over and so when I do that, I get 2.8 million people per year, units there. For the next one, I want to find the intervals on which the function is increasing or decreasing. And so what I'm looking for here when it says intervals, it means intervals of x values. So I really want to be looking at what's happening on the x-axis. And so if I look here, I can see the function is increasing here until I get to this point, and then it starts to decrease until I get to here, and then it starts to increase again. And so when I write down the interval, I want to be looking at the interval of x values. And so I'll go like this interval is the interval of x values on which it's increasing. So that's what? Negative infinity to 3. And then the other interval where it's increasing looks like it starts at negative 1 to infinity, right? And I didn't include those endpoints just because, you know, you can't say that it's increasing at that max or min point because it's like neither increasing nor decreasing at that point. And then the interval of x values on which it's decreasing, I'm just looking at the x values here, so it looks like from negative 3 to negative 1.